Today marks one of the biggest milestones in India's space history. While private companies have supplied components for ISRO for decades, but Vikram-1 is the first complete orbital launch vehicle which has been designed, built and operated by an Indian private company. So this mission signals that India is transitioning, the space sector is transitioning. And India has marked the beginning of commercial launch era, and this also strengthens the ambition to become a major player in the global space economy. Hello everyone, welcome to Vajiram and Ravi's Flash News. My name is Shubhangi Singh, and in today's session we are going to understand that how Vikram-1 has made history, not in 1, 2, 3 ways, rather in 7 ways. So let us begin by understanding that what exactly has been done that is being talked about as a huge achievement. So what we are looking at as of now, that a private space sector company, that is Skyroot Aerospace, they have launched their first privately developed orbital launch vehicle, and now this has been done under the name Mission Aagaman. Aagaman means arrival, and this is symbolic of the fact that India's private sector has also arrived in the launch industry. Now, as I said, why this becomes very historic is the fact that this shows that India is transitioning from a government monopoly-led ecosystem of the space sector to where public-private partnership model is unfolding in real time. And this is about how new opportunities will be created, new horizons will be touched, new missions will be coming, and it would be not just by the government. Now let us go back to with what we started our conversation with, 7 historic ways in which Vikram-1 has launched off. So let us begin with the first one. When we are looking at the first historical achievement, it is more of an institutional achievement rather than a physical or innovational one, because this is India's first private orbital launch vehicle. First Indian startup, they have made their first launch vehicle, and this is an independent attempt to send off this particular launch. Now this shows that there is capability in indigenous private industry and indigenous private launch capability as well. And this automatically reduces our dependence on government launch systems. Now the next 2 achievements, they are more related to material engineering. So basically the second one what we are seeing is related to all carbon composite structure. So when we are looking at this entire launch vehicle, what we see that it has been made using lightweight carbon composites. That means given the strength to weight ratio, weight is lighter, strength is better, and that means payload efficiency of this launcher would be way better. Second is also again a material milestone, as I mentioned, that this is going to be India's longest monolithic, that means single carbon composite rocket stage. Now when we are looking at the stages of rocket launch, what we see in this particular context, that the first stage of this rocket launch, that has been built in a single integrated composite structure. That means it has not been broken off and connected, it is a single piece. That is why monolithic word has been used here. And this shows that how advanced indigenous manufacturing capability in India is. That means structural joints are reduced, so are the vulnerabilities and weaknesses as well, and that is why the reliability will be enhanced. Now that 3 achievements are covered, let us move to the more that Vikram-1 has achieved. Now these are more on the mechanical front as compared to the institutional or structural front. Another big achievement that we are seeing here is the fact that this is India's first fully 3D printed engine on an orbital rocket. When we are looking at traditional rocket launchers, they require individual manufactured units, and when we are talking about additive manufacturing, which is 3D printed manufacturing, that eases out the process. It ensures that components are limited, manufacturing is faster, and the production cost is lower. And because of this, because there are fewer components, the precision here is improved, the reliability is enhanced. So all of this orbital adjustment module that has been created, this is powered by a liquid engine that has been created through additive manufacturing, that is 3D printing manufacturing. Apart from that, equally important is how the shock separation looks when we are talking about the rocket launcher, because it impacts the satellites which are present. It impacts the payload which is present. So what we are seeing in this particular orbital launcher, that advanced ultra low shock, that means the shock that will be created during separation, which is very limited, especially when we are talking about minimizing vibration during stage separation. So all the sensitive satellites, they will be protected and mission reliability will be enhanced. So when we are talking about the mechanical achievements, they are about how this orbital launcher is more and more reliable, and that gives us better guarantees for the upcoming projects. That gives us a solid answer in the private ventures and the private capability as well. Now that we have covered 5 last 2 achievements, let us look into that. The 6th one in front of us, yes, it is again on a mechanical front achievement, but you have to look at how it contributes to a global issues where debris accumulation across space in form of satellites which are not functional is a big problem. So what we are seeing on Vikram-1, that there is a proper space debris removal technology demonstration that will take place. There is an additional payload which goes by the name Embrace, and this will demonstrate robotic arm technology. And when in future, when we are talking about active debris removal missions, this will be the one which will be providing the base knowledge, base demo, and it directly addresses the challenge of orbital congestion, which is a reason for dysfunctioning of multiple satellites that are already placed in the orbit. And the last one, this is not institutional, this is not mechanical, this is symbolic. This is where we see a lab-grown diamond has been sent to space. A handwritten letter by our PM has been sent to space. When we are talking about this lab-grown diamond, this payload has been named as Cosmic Bloom, and this is a very unique fusion of not just science but also technology and art. This is one way of showing that how technology is booming, how it can be changing things, and how commercial payloads can be of variable nature and what role they can play. This is clearly just present there to show the new possibilities. And these are the 7 remarkable ways in which Vikram-1 today has created history for us. Vikram-1 is not just an orbital launcher which will be taking payloads to the orbit, but rather it is taking India's dream of expanded space sector, being a global player, to the horizon, because this is the start where we will be seeing that a whole new acceleration to India's commercial ecosystem will be seen. There will be better support to the in-space reforms which have been announced, especially to the 2020 space sector reforms when we are talking about. It will enhance India's position, especially when we are talking about launch market. We can commercially gain, we can be a main player when we are talking about launch market where the names and numbers are limited. And overall, when we are looking at the vision of 44 billion Indian space economy by 2033, this is a huge step towards it. Now, what are your thoughts on this? Let me know in the comment section. I'll be waiting for your suggestions, understanding, or if you have any doubts, I'll be leaving you here with a prelims practice question. Very basic conceptual question. Let me see if you are able to answer this. Let me know the answer to this in the comment section. I'll be waiting for your answers as well. That was all from my side. Thank you so much.